Question 4. The time it takes students to complete a quiz has a mean of 20.5 minutes and a standard deviation of 15.4 minutes. Okay. What is the probability that a random sample of 40 students will have a mean completion time greater than 25 minutes? Okay, so the first thing that I'm going to do is I'm going to take that first sentence, and my interpretation of this is that it's describing the population. Okay, so the mean of the population, which we label mu, is 20.5, and the standard deviation of the population, which we label sigma, is 15.4. Okay. And then the question is asking about the mean of a sample. Okay. In other words, it's asking about values of x bar. So to answer this question, we need to create the sampling distribution of x bar. Okay. So we've got to determine the shape of this sampling distribution, its center, and its variability. All right. Now, shape seems like it's a tough question because nowhere in the prompt does it mention anything about shape. Is it skewed right? Is it skewed left? Is it symmetric or normal? Okay. But it does tell us that the sample size is 40. Okay. And that's good because the central limit theorem tells us that if our sample size is at least 30, which it is in this case, then the sampling distribution will be approximately normal. Okay, all right, so we've determined what the shape's going to be. Okay, the center and the variability. Okay, so to figure out those things, we're going to refer to our formula sheet here. All right, so this is a question about the sampling distribution of x bar. Okay, here's how we would find the center or the mean of that distribution. Okay, it's just equal to the population mean. All right, pretty simple. Here's how we find the standard deviation of that sampling distribution. Okay, it's the population standard deviation divided by the square root of n. All right, so the mean of our sampling distribution is just the same as the population mean, which in this case was 20.5. Okay, the standard deviation of our sampling distribution is equal to the population SD divided by root n. So that's going to be 15.4 divided by the square root of 40. And that is approximately 2.43. Okay. So now that we know the shape, the center, and the variability, let's sketch. Let's make a sketch. All right, so there's our approximately normal shape. We'll label it N for normal. We know that the mean is 20.5 and the standard deviation is 2.43. So that's the mean and that's the standard deviation. All right. So at the very least, draw a line down the middle and label that with the mean value 20.5. All right, now our question was to find the probability that the sample will have a mean greater than 25. Okay, so 25 is going to be somewhere here in the right tail. Greater than, so we're going to shade to the right of that boundary value. All right, there's a couple ways we could approach this. I like to standardize or find the z-score. So take the value minus the mean, divide by the standard deviation, and that's going to give us, let's see, 25 minus 20.5 over 2.43. Okay, I got 1.85. Okay, and then now we can go to table A and then figure out the area in that right tail. Okay, so 1.85. 1.85 is right here. Okay, 9678. Okay. And we see that as one of the answer choices, okay? But you should realize that that doesn't make a lot of sense because this is a number that's pretty close to 100%, but what we shaded is clearly less than 50%. It's a small amount. Okay? So again, what's going on here is that this number represents the unshaded part of the curve, so we just have to subtract that from 1 to get the shaded part of the curve. So 1 minus 9678 is 0.0322. And that's going to match up with choice B.